try to conclude this displacement current. So now the Ampere circuital law will be inconsistent to explain this concept. See here, based on your displacement current information. So I had HDL, right? What is your Ampere circuital law? HDL is equal to what? I, isn't it? But what is I now? This is an inconsistency of ACL with respect to time varying field. So this is a very important question with respect to your exam point of view. See, there will be an inconsistency in ACL because this I is not IC only. This is now IC plus what? IC plus ID. And what is this ID? ID is displacement of electric field. Displacement of electric field. Now the Ampere circuital law, which was equal to I only, will be modified as IC plus ID. And now we are going to derive the equation for a modified Ampere circuital law stating the inconsistency of Ampere circuital law, which we have derived previously. So you might get a question like, what is the inconsistency? What is the inconsistency of ACL? State the inconsistency of ACL. Okay, what is the inconsistency, or state the inconsistency of ACL and obtain the solution using displacement current. Using displacement current or modified Ampere circuital law. This is one way of asking this question, or the same question in simple statement. Obtain modified Ampere circuital law. That's a simple statement. Modified Ampere circuital law. State and prove. Okay, state and prove modified Ampere circuital law. Both are one and the same. But again, we are trying to explain the modified Ampere circuital law. What was the necessary to modify this Ampere circuital law, which was HDL is equal to I, and now it got modified to I plus ID. So why? And so why? The answer is due to the inconsistency in time varying fields. You have to mention this. You have to mention this and then say it has been modified to this. Okay, so we shall try to represent this modified Ampere circuital law both in integral form as well as in a point form. So we know that the point form of Ampere circuital law will start with the proof. So from the point form of ACL, we can say curl of H is equal to what? J. And how did you get this curl of H is equal to J? Please refer to the previous class notes. Or else you can say H dl So line integral is equal to surface integral J ds. So what is JDS is equal to, this is the total current I. So how to convert this line integral to the surface integral? So I can say curl of H ds is equal to surface integral J ds, which is equal to I again. So now curl of H is equal to J. If you try to equate this integral component, I had quickly derived the point form of your Ampere circuital law. So this is how I have obtained point form of Ampere circuital law. So this is one part. So if you want, you can refer to this. So curl of J is equal to J. Now if I take the divergence here, take divergence on both the side. Take divergence on both the sides. What happens? Del dot curl of H is equal to del dot J. Call this as equation 1 and this as equation 2. By taking divergence on both sides, you get del dot curl of H is equal to del dot J. What is divergence of curl? Guys, I repeat, can I call this as curl? Curl is what? It's a circular motion. So this is a curl of any given vector. Here it is H. And what is divergence? Divergence of any given vector would be like this. So from a point, if you have a diverging vector, if you have a vector going away from the point, so this is divergence. So what is divergence? Are you realizing this concept? What is divergence of this curl of H? This is 0, right? So there is no divergence for this curl vector. There is no divergence for this curl vector. So this quantity will be equal to 0. Since del dot curl of H is equal to 0, therefore del dot J is equal to 0. Call this as equation 3. Because divergence of curl is equal to 0. But what is del dot J? What is del dot J for time varying fields? Using continuity equation, it is minus dou rho v by dou t. But del dot J is equal to what? Minus dou rho v by dou t. This is due to continuity of current. This is due to continuity of current in time varying fields. So how to understand this? Del dot J is equal to minus dou rho v by dou t. Again, I will take an analogy here. If you have a balloon filled with a water, so this I will call it as rho v, volume charge density or volume of water inside the balloon. And if I puncture this balloon, so you could see the water flowing, or there is a current, right? Or there is a current on this surface. So you call this as divergence of water. So J is density. Divergence of water density is equal to the negative. Negative means what? Decrease in rate of change of volume. That means water is getting emptied inside this balloon. So I call this as minus dou rho v by dou t, which is equal to what? Which is equal to the total current density or the divergence of current density on the surface. So this is a continuity of current in time varying fields. So if you try to understand this minus dou rho v and compare with this equation 3 here, so this is false here, right? So this cannot be true, right? So this cannot be true here. So dou rho v by dou t is equal to 0, and it cannot be applicable for time varying fields. So with this equation 3 says that d rho v by dou t is equal to 0 and not applicable. Guys, I repeat, this is not applicable to time varying fields, and this is called as inconsistency of your existing Ampere circuital law. This you have to state or mention before you say I will introduce the term called displacement current. D rho v by dt is not equal to 0. Right? D rho v by dt is not equal to 0. Hope you understood this inconsistency now. So therefore, due to this inconsistency, this was the motivation for Maxwell to introduce the displacement current term. So he introduced displacement current. I represent it as ID, and displacement current density as JD, and modified the Ampere circuital law. Now we shall see what is that modification been done. So he modified Ampere circuital law. And what is that modified Ampere circuital law? So the Ampere circuital law, earlier it was curl of H is equal to J. Now the displacement current density JD is added. So this is a modified Ampere circuital law. Now again we shall try to prove what is this JD. I want to calculate this JD is equal to what? So again I will take divergence on both the sides. So I'll get del dot del cross H is equal to del dot J plus del dot JD. So now this is equal to 0, which is equal to del dot J plus del dot JD. Therefore, del dot JD, displacement current density, divergence of displacement current density, is equal to minus del dot J, which is equal to minus dou minus of minus, sorry. This is equal to minus of, what is del dot J? Del dot J is equal to minus dou rho V by dou T, which is equal to plus dou rho V by dou T. So I can write del dot JD is equal to del dot JD is equal to dou rho V by dou T. But we know that what is del dot D is equal to? Del dot D is equal to, it is rho V. Therefore, I just want to introduce this electric flux density here. Why? Because my displacement current is equal to what? The displacement of electric field. which we have discussed while introducing the displacement current. You watched previous video. So this will be del dot t by dot t, which I can write it as del dot dot d by dot t. Now if you try to compare the divergence coefficients, JD is equal to dot d by dot t. JD is equal to dot d by dot t. Substitute this equation into this modified Ampere circuital law. I would get curl of H is equal to J plus dou D by dou T. This is another Maxwell's equation, that is fourth Maxwell equation in point form. This is again one of four Maxwell's equation in point form. Do not worry about Lata Madam session. Lata Madam session will start after 9:45 or 10 after I complete this session. Okay, so I have informed her you may join some 20 minutes late to her class. So we have just obtained this modified Ampere circuital law. I can call it as modified Ampere circuital law, which is again one of the Maxwell four equations in point form. Any doubt? So this is a point form or a differential form. So this was about the displacement current, where again a modified Ampere circuital law, where we mentioned the inconsistency. This is one part where I mentioned inconsistency of Ampere circuital law with respect to a time varying field. Then I modified ACL, which appears like this: curl of H is equal to J plus dou D by dou T, by introducing the displacement current concept, and this was a point form or a differential form. Now if I want to calculate, because in the question I need to calculate both point form and integral form equations. So in order to find the integral form, so what I'll do, I'll take the surface integral on both the sides. I'll take surface integral on both the sides of above equation. I will get surface integral curl of H ds is equal to surface integral J ds is equal plus surface integral dou D by dou T into ds. Okay, so surface integral can be converted into the line integral using Stokes theorem. So it will become H dl. Only the left hand side of your equation will be converted to the line integral. And what is this? This is I. And now I'll call this integral coefficient, that is surface integral dou d by dou t as id. Therefore, I could write the total equation as, and I'll call this as conduction current and this as displacement current. So what is line integral of HDL? So it is the total current which will be equal to the conduction current plus the displacement current. I hope we had an argument on this. That is current, conduction total current is equal to the conduction current plus a displacement current. So you remember this. So there was a current here in the loop. I call it as conduction current, and here I call it as displacement current. And this displacement current is the rate of change of electric flux density. And this is an integral form. See, this equation is an integral form. In order to obtain the integral form, what I did, I just took the surface integral on both the sides of this equation and I converted this surface integral to a line integral to obtain line integral of HDL, and what is conduction current and what is displacement current. So IC is the conduction current, which is equal to surface integral J ds, and displacement current is equal to surface integral dou d by dou t into ds. This is conduction current and this is displacement current. So any doubt? Yes, let me know if you have any doubt. Fast.
No, sir.